For the electrochemical cell descriptions, I've put together some basic pieces that I know we're going to end up using. So I've just made a collection of arrows and I know I have to come up with the cathode and the anode, so I'm going to have to put them somewhere. And I also know that I'm always going to have to come up with the salt bridge. So I've put together some pieces down here for the salt bridge and the electrons. Our very first one is the iron and lead cell. And so I've also made this here, some iron and lead ions, because I know I'm going to have to put them in someplace. The other part that I took straight from the table, which was the lead reduction half and the iron reduction half. So as we go through and we describe the cell, I'll be able to move things into their right positions. So the first thing it talks about is write each equation for the half reaction as it will occur. And as it will occur means that I have to take a look at my table. Lead was written above iron. Lead is more positive than iron, so it's the reduction half, and it's going to happen exactly as written. But the iron, which is lower down and less negative, that's the side that's going to get oxidized. So it, as it happens in the cell, needs to be reversed. So I've just reversed it, including reversing the sign. So those two are the reactions that are going to be happening in the half cells. To start putting things in place, I can just build the cell, and then I can go through and label it with all the directions. So I know I have to have lead, so one of these has to be a piece of lead, and the other one has to be a piece of iron. That in the solution underneath them, they would have their corresponding ions, so the lead ion and the iron ion go in there. In the salt bridge, there's going to be a direction of flow. One is going to flow towards this side where the iron is, and the other salt bridge ion is going to flow towards the lead side. And now to start putting things into their proper places. Oh, I can also put, of course, we're going to have these ions in here. That in order to get lead ions, I had to have dissolved something like lead nitrate. So the first thing I have to do is come up with which side is the anode or the cathode, because that's going to solve or answer most of the other questions. And whichever one is more positive, or which is closer to the top as originally written, which was of the lead, that is the cathode. So this side is the cathode, which means that the iron is the anode. Now that I know this, I can quickly say, all right then, electrons always flow from the anode to the cathode. So my electron flow is done. In the salt bridge, the positive ion flows towards the cathode. It is replacing the lead, and the negative ion flows towards the anode. So when the electrons move from the iron to the lead, this becomes temporarily, this piece of lead becomes temporarily negative, which means it attracts the lead ions out of solution. And as the iron, or as the electrons leave the iron, then that means that it releases iron ions into solution. So the reason that the positive ions in the salt bridge are flowing in this direction is because the positive lead ions are disappearing, and the potassium is positive and it's replacing this missing positive charge. I don't have any use for these arrows because they're not describing the direction that my stuff is flowing, so I can ignore them. And the only remaining thing is to figure out what would be the total voltage. And to do that, we can take a look at the original ones, let's see, there's that half and there's this half. So when we look at the original reactions, these two here, the top one is the cathode, the bottom one is the anode, and our equation is that the total cell potential is the cathode reduction half minus the anode reduction half. So this will be negative 0.13 minus negative 0.44, and you get a total electrical voltage of 0.31 volts.